Hello, I'm Professor Gabriel Kabanda. I'm very much excited today to be presenting this keynote paper on cybersecurity risk management plan for a blockchain technology application model. This is a paper that is purposed to build up on an understanding of the modern trends in cybersecurity and then also apply them then to blockchain technology and with particular emphasis on the benefits to the financial services sector. We take note of the phenomenal growth in the use of internet-based technologies, which are subject to cyber attacks, and so cybersecurity is essentially the practice of protecting systems, the networks programs from digital attacks. So a blockchain now comes in as a data structure which stores transactional records in the form of a block which is chained together. One can also look at a blockchain like a digital ledger of transactions that is duplicated across a network. Now, for us to improve cybersecurity, we then may have to make use of machine learning and other artificial intelligence paradigms. So this paper is purposed to determine a cybersecurity risk management plan, develop a blockchain technology application model that manages cyber risks and vulnerabilities, and then also ascertains how the framework of blockchain technology and cryptocurrency addresses cyber risks and creates value to the financial services sector. As I share with you shortly, it takes on the pragmatism paradigm as part of the methodology, which is intricately related to the mixed method of research, and with some of the things that I did with the focus group consisting of hundreds of my students on the master's programs at the University of Zimbabwe. So this is what this paper is all about. So let me start now by just taking you through the cybersecurity trends. Cybersecurity focuses on protecting systems, networks from malicious attacks. It is a collection of policies, techniques, technologies, and processes that work together to protect the confidentiality, integrity, and availability of computing resources, programs, and data. And the trends that we see these days, particularly as we look at the beginning of 2021, one looks at the phishing and social engineering, which is a practice where people are sending fraudulent emails that resemble emails from multiple sources. There's ransomware, which is a type of malicious software designed to extort money by blocking access to files or computer systems. And there's Internet of Things that also increase the vulnerability of some of the systems. But let's not also forget that cloud vulnerability is also another source of problems because we are relying and outsourcing these services from other organizations. So these kind of trends are worth noting. As we look at the network, a little more details, we take note that in any computer network which is mindful of cybersecurity, there's always need to structure it in 3 dimensions. There have to be some sensors, facilities to be able to detect what is getting to the network. There have to be some analyzers. These are engines and facilities that will analyze what gets in and the level of intrusion. And then there must be the user interface that interacts with the user. So as we look at all these components in a network intrusion detection system, you then become aware of the level of risk that manifests. Cybersecurity risk then comes in as a way for us to understand the technologies and practices and policies that address the threats and the vulnerabilities on the network, so that whatever comes through, and if it is a risk, it must be taken care of before it happens in a way. The basic understanding of blockchain is a concept where if a person wants to send money to a person A wants to send money to person B, the transaction is represented by a block on the network. The block then is broadcast to all the participants in the network, and the participants then agree to validate the transaction, and then when the validation is done, then the transfer of the money can then take place. So blockchain technology is essentially a data structure which stores transactional records in the form of a block chained together, stored in several databases, and duplicated across the entire network, whether within the organization or even with their own partners. So blockchain is a type of a distributed ledger technology in which transactions are recorded with an immutable cryptographic signature called a hash. Each block in the chain contains a number of transactions, and each time a transaction occurs on the blockchain, a record of that transaction is added to every participant's ledger. Now, this brings in the need now for us to also appreciate what is called cryptocurrency, which is a digital currency that is secured by cryptography, which makes it nearly impossible to counterfeit or double spend. Many cryptocurrencies are decentralized networks based on blockchain technology. So there are some of the basic terms we want to look at as we discuss this paper: cybersecurity, blockchain technology, and cryptocurrency. And we appreciate the benefits of blockchain right at this beginning, that you can make savings in terms of time. There are cost savings, it's tighter security, enhanced privacy, improved auditability, and increased operational efficiency. These are some of the basic benefits. The blockchain relies entirely on concepts where two networks can be connected together, computer to computer, which is a peer-to-peer kind of network, or it could be a distributed consensus where bigger networks are linked together and they agree on many things. But above all, there is a public key cryptography that is at the center of all the movement that takes place. So the blockchain, therefore, can be looked at, as a structure with the four pillars. One, there is the distributed shared ledger, and two, there is the cryptography, and then three, consensus, and then smart contracts that come with it. In artificial intelligence, we are looking at programs that can sense, reason, act, and adapt to what happens in an environment. But one of the groups that is of particular interest in this discussion is machine learning, whose interest is essentially on algorithms whose performance improve as they are exposed to more data over time. And we may even get to the extent of using deep learning, which is a subset of machine learning, which works on various neural networks we have in an organization. What is machine learning? Machine learning is the process of instructing computers to learn. Machine learning algorithms, these are inspired by the central nervous system, often referred to as artificial neural networks. And these involve programming computers to teach themselves to data instead of instructing them to perform tasks. So these machines learn from the data. So machine learning is known essentially for automating the analysis of large volumes of data sets in order to produce models that can, from which one can learn. So we then are able to come up with three classes of machine learning in this process. The first one is supervised learning, where the training examples are given to the methods in the form of input labels with the corresponding outputs. We have another category called unsupervised learning, where unlabeled inputs are given to the methods. And then there's also reinforcement learning, where data is used in the form of sequences of actions, observations, and rewards. And these three types of learning can be used in different organizations for different purposes. The levels and major applications of machine learning in life include the facial and pattern recognition, virtual personal assistants, predictions whilst commuting, video surveillance, social media services, and even, for example, on Google, the machine learning is used in many ways. One is looking at Google searches and so on. So this is one area where such search engines, have been really well empowered and been well closed with some of these facilities. The statement of the problem which I'm looking at in this paper is a simple understanding based on the phenomenal growth in the use of internet-based technologies. And we're talking about blockchain as a data structure which grows to become a digital ledger. But now we are concerned with the need to improve cybersecurity. And this is where now machine learning is now considered to become important in the automation process of those large data sets, so that we can produce models and relationships. So there's a need for us to come up to be very proactive on our security measures against cyber attacks, and in particular cyber risk management plan, which is really the center of this particular central focus of this paper, so that this can lead us to the development of a blockchain technology model. So we want to develop a blockchain technology application model that manages cyber risk. So that is the main purpose of the paper. And the objectives of the research paper were, first of all, to determine the cybersecurity risk management plan that incorporates machine learning algorithms. Two, it was important to develop a blockchain technology application model that manages cyber risk and vulnerabilities. And then thirdly, it was important to ascertain how the framework of blockchain chain technology and cryptocurrency addresses cyber risks and creates value to the financial services sector. The research questions are related to the objectives. It's essentially just translating those objectives in the form of questions, but they're looking at the 3 issues in particular. A very quick navigation of literature shows us that we should appreciate the cybersecurity framework, and the most commonly used cybersecurity framework is the National Institute of Standards and Technology framework developed in the US. It's a common framework used by many countries in the world, but it is known to have 5 major components, which are essentially focusing on us to be able to identify who is on the network. We must be able to protect the resources. We must detect the intrusion as it comes. We must also respond and ultimately must recover. So those are the 5 areas. So with this NIST security framework, it seeks to provide organizations a common way to describe the current cybersecurity state, describe the cybersecurity state itself, and prioritize opportunities for improvement on the network, and so that one can make progress on the opportunities that are there. The underlying theory behind the NIST framework is the general deterrence theory, which is an understanding that it's important to deter intruders using disincentives and policies and so on. There's also need to handle some prevention mechanisms, which may start with physical obstacles, but we also bring in authentication and firewall protections and many other things. But as you are aware, firewall protection has become inadequate these days because of complexity associated with intrusion. But the prevention is important. And there's also need for us to focus on detection, which is a process of discovering security breaches, the internal system controls, and many things, and then until we come to the remedies that are necessary in the process. As we look at this kind of literature, we have to appreciate the need for us then to invoke models applied to certain algorithms. So our focus then is to be able to build models that can make use of certain algorithms, so that as we generate those kind of models, we can be able to apply machine learning methods or any statistical methods for us to understand and appreciate what has happened over the years. The history of blockchain is something that started some years back, right from the 1990s, where people started looking at the concept of distributed computing. But this grew over the years when Nakamoto in 2009 developed the Bitcoin and introduced the notion of blockchain to be used as a decentralized and distributed ledger. So it then grew to the extent that people were now looking at the deployment of cryptocurrency around 2012, and which then got developed further to the level of using currency transfer and digital payments around 2013. And since then, blockchain has emerged from around 2018 up to now. It has emerged in various applications, and this is why we are focusing on blockchain technology and bitcoins. Bitcoins and cryptography are associated with a very simple understanding where we have to look at the anonymity of the bitcoins. We don't need to know where the bitcoins are coming from, because each transaction has got a unique address that is not shared publicly. There is a volatility of bitcoins also that is associated with this, where the cryptocurrencies arise from the fact that there is no central authority regulating them, and their supply is fixed. So there's no policy in place to regulate the growth of cryptocurrencies, such as the monetary policies we often deal with when looking at the traditional financial services sector. So due to the fixed supply of Bitcoin, the uncertainty is there. There's a lack of adequate infrastructure associated also with the use of ICTs in some countries, particularly in developing countries, but the Bitcoins are growing in use, and one has got to look at the risks associated with those. But what are the benefits of blockchain technology? There are essentially 4 main benefits. The first benefit is decentralization, where customer records stored in a decentralized fashion reduce data protection and cybercrime risks. There is the improved privacy control, number 2, which is about improved privacy entrusted on a single third-party application. We also have a benefit of immutability, where once recorded in a blockchain, the customer information stays forever and it cannot be changed. So it enables accurate tracking of customer information. We have also the benefit of customer profile management and product personalization, where the blockchain technologies can enable much more accurate and secure privacy as we look at those kind of records in many ways. What was the research methodology used? The research methodology that was used in this paper is one of pragmatism paradigm, which is intricately related to the mixed method research. The paradigm comprises of the epistemology, the ontology, methodology, and axiology that comes with it, so that we are aware of the ethical issues associated with the use of that kind of methodology. Pragmatism is a philosophy of knowledge construction that emphasizes practical solutions to applied research questions and the consequences of inquiry. And so, put simply, we see pragmatists opting for methods and theories that are more useful to use with specific context, not to those that reveal underlying truths about the nature of reality. So in this research, a mixed method approach was taken, which involves mixing both qualitative, so it's essentially focus group discussions, and the quantitative methods, which was an experiment that I did in order to develop the blockchain technology application model. The focus group comprised a total of 100 students, from the master's students attending the applied business informatics module, which I teach at the University of Zimbabwe. So that's how I put the groups into focus groups to pick up these issues from students. The data analysis covers a few areas, but let me start off by sharing the cybersecurity national challenges. The focus group discussions brought to attention and this research that there is a problem on the clarity of responsibilities or ownership of who deals with what regards cybersecurity. It's a common problem in Zimbabwe, common problem also in many other neighboring countries in Southern Africa. The ubiquitous nature of technology and advances in the Internet of Things presents serious challenges, where smaller and smaller devices are increasingly getting added to the network, and this also brings in additional complexities, and cybersecurity strategy becomes important. But the sad thing is that in most of the organizations in Zimbabwe, or even in Africa generally, cybersecurity strategy is not part of the business strategy. It's something which is always an afterthought, added much later on. There is an over-dependence on one service provider, so that in the unlikely event of a breakdown, then the risk is very, very high. There's low affordability and availability of electricity and internet, particularly on the majority of the citizens in the country. And so there are some of the national challenges we face with regards to cybersecurity. The cybersecurity framework that one has to construct at a national level, from which then internal organizations can operate, requires us to attend to the issues to do with the infrastructure, the legal issues like cybersecurity bills and acts, the harmonization of pieces of legislation so that one is able to handle and to deal with any criminal activities decisively and properly in the course of law. Balancing harmonization and country-specific issues is also another challenge, and some of the systems are often disintegrated, and one is not able to do many things. But there is also a challenge on that framework with regards to education and awareness campaigns. These are not coordinated properly and smooth in a way, whilst also the end users and organizations face challenges to do with the affordability of the internet and the funding to deal with operations that are there. So there is a perceived low susceptibility to attacks, and the lack of adequate frameworks that speak to their cybersecurity needs. And so these are some of the challenges that then we face as we try to create a cybersecurity framework for our nations. So it then takes us now to the stage where we say, with those kind of challenges at the national level and organizations around us, how do we take care of the risk management process? A risk management process requires us to focus on risk recognition, risk prioritization, and risk management, with all the necessary kind of questions as we move from stage to stage, so that we come up with a much simpler way of managing that. What we're interested in and what came out of this research is an information risk management process that is followed, which starts from the risk communication and building up on the context in which we are building up cybersecurity and blockchain technology in the model. We have to deal with this risk identification and then risk estimation and do the evaluation, from which then we can do a risk treatment and where we manage those kind of risks more precisely. So the risk management plan will then have 5 major components. The first one is the NIST cybersecurity framework, which identifies, protects, detects, and responds to cyber threats as they occur. The second stage element is to look at the risks that we face, and some of these risks may be to do with the technology, with information, the business resilience, reputational, and regulatory risk. And then the third level focuses on the governance risk itself and compliance. For example, if there is IT governance in an organization or a general governance which looks at those issues broadly, it's important to manage those kind of risks at a very high level. Third-party risk management is also important and must be taken care of because it can infiltrate in the organization. But there is need then to have at a separate level specific focus on policies, standards, and procedures to deal with risks and to deal with other operations that come with it, so that we are able to do a proper risk assessment from time to time as you operate and make use of these technologies. The blockchain cyber vulnerabilities that were identified by the research, these include the blockchain code vulnerabilities, where you're saying the blockchain applications, they use software that naturally may have coding errors, and this may introduce cyber risks. And because we depend, and some of these systems depend entirely on the encryption algorithms that are used. There is also a vulnerability from the platforms themselves. The blockchain applications typically run on general purpose operating systems and platforms that are subject to non-hardware software vulnerabilities. And so these must be taken care of. There is end user vulnerabilities, where we look at the age of any blockchain where users interact with the system, and there's always a gateway for cyber attacks, online wallets, and many other things that come with it. So these vulnerabilities must be given sufficient attention. And we noticed also in the research the wallet controls that service providers such as digital wallet providers have managed to provide key management services and which minimize individual risks. But however, these services depend on passwords, device authentication, such as using a particular mobile phone or other user authentication controls. And these wallet controls are very much vulnerable because impersonation, phishing, malware, and other end-user attacks can be activated and produce a greater risk. The model structure, therefore, for the blockchain technology that we ought to have developed was developed based on an approach that deals with two major layers, where we focus on the commercial banks at their level, and then we also then look at the next layer, which focuses on the users, whether they are individuals or businesses. So we have to separate the two, and those are the two layers in which one looks at as we develop the blockchain technology model. So I developed this model structure for blockchain technology and cryptocurrency that is based on these two layers, but it has got components that cover the specific components on the distributed ledger. So there must be a distributed ledger with cryptographic functions that must be operational. There must be a public-private key cryptography, a way in which the senders and the transmitters of information, or receivers, agree on the cryptocurrency. Nodes must be identified, which particular organizations or active networks components must be involved in the blockchain technology transfers. Then tokens can be produced, like the tokens that are used in payment of electricity bills and or other similar kind of services. So the tokens can be generated that have got monetary value. And then in the end, we then come up with the blocks in a blockchain. So these five main things are things that can come out of the blockchain technology and the cryptography structure that you wanted to develop in the research. As we go up to the level of the banks, one must then look at a central bank, and the central bank itself must have a digital currency, which is essentially the value of digital representation or electronic storage and cryptographic transfer that is expressed digitally, stored electronically, and encrypted for transfer of ownership subject to the financial laws and regulations in a country. So what are the functions of the central bank digital currency? We see that kind of currency being one that gives centralized issuance, transferability, storability, offline transaction, and accessibility of other things that are there. The central blockchain and cryptocurrency application model then, in a sense, will have a regulatory layer where the central bank comes in Then in the regulates what happens also in the commercial banks and financial service sector. Then there's a network layer, which is a bridge between the top regulators and ordinary users, and this adopts different kinds of structures. Then there's the user layer, where we focus specifically on the individuals and organizations that are using blockchain technology. And lastly, there was a need to come up with an explanation. So how does the framework of blockchain technology and cryptocurrency address the cyber risks and creates value? The first thing we noticed that came from the research is that there's minimal transaction fees, there's accessibility, instant payments. Blockchain technology offers a more secure and trusted system than centralized financial systems. There's also security, because blockchain records are distributed over a network of computers, making it extremely difficult for hackers to infiltrate. And transparency is also one of the dominant things that comes out for anyone to be able to review the transactions and make decisions based on observable cryptocurrency. And in conclusion, having developed the blockchain technology application model, it was important then to point to the future and come up with improvements as we now build a machine learning system that picks it up so that we can manage the cyber risks in a manner which does not require much human intervention. So the machine learning paradigm now comes in helping us to handle the pre-processing of anything that has to take place before we get into the real activities. The pre-processing is managed by machine learning. Then there's the learning process, where the learning algorithms help us to come up with appropriate models to select and learn from the data, so that the trends and activities due to with risks and attacks are monitored and controlled meaningfully using artificial intelligence techniques, so that in the end you come up with a model that can learn with very minimal intervention by the person. This can be looked at from supervised learning perspective. One can also look at from reinforcement learning mechanism, or even unsupervised learning, where we can explore the structure of the data to extract meaningful information that is required. But the future for this kind of research, as we deal with machine learning, is for us to be looking at lifelong machine learning, where we want systems that perpetually continue to learn and acquire things as we look at. So in conclusion, this paper presented and covered how blockchain adds value in payments. And we noticed that we learned that the cost, usability, and anonymity issues that come out from the blockchain. The key aspects of Bitcoins that came out also clearly from the paper included the confidentiality, integrity, authenticity, non-repudiation, and availability of the currencies that are being used. So how does the blockchain model address cyber risks? We noticed and learned the double, that there is no double spending. We can see the unforgeability, that the non-repudiation and the verifiability that comes with the use of blockchain technology. The benefits of blockchain that came out with this paper include the cost reduction, faster transaction, improved security, improved data quality, digital currencies are used which are easier to manage. There's compliancy and accountability also clearly recorded. Increased transparency in many things that happen. So the money transfers are handled so well that it's very difficult to forge and or allow any fraudulent activities to be perpetrated on the network. So these are some of the basic benefits of using blockchain technology. I believe this model can be useful, and it can be used and be developed to a great extent as you use more of machine learning and developing different platforms and technologies. And we can be able to adopt this kind of technology once we take care of the hindering factors as well as also the circumstantial factors. So I want to thank you very much for this presentation that was meant to share with us how we can create a blockchain or develop a blockchain technology application model and at the same time manage the cybersecurity risks. So thank you very much. I'll be most delighted to take any questions or issues that require clarification. Thank you.